When you die, where do you go? Do not think about heaven or hell. I am asking in the language of physics, where do the atoms that make up you actually go? Right now, inside your body, there are about 7 times 10 to the 27 atoms, a number far greater than the number of stars in the observable universe. And when you die, not a single one of those atoms disappears. Not a single bit of energy is erased from the cosmos. So if nothing vanishes, what is it that truly leaves? What changes when a warm body that thinks and feels suddenly becomes silent? If every particle is still here, then what exactly is gone? Today we look directly at that question. Not through belief, but through physics, through atoms, through energy. And once you understand this, you may never see death the same way again. Light a candle and watch it carefully. The wax melts, the wick glows, the flame flickers, and after a while the candle is gone. It feels like something has been destroyed. But nothing has actually disappeared. The wax has not fallen out of existence. It has changed form. The carbon atoms in the wax have combined with oxygen in the air to become carbon dioxide. The hydrogen has combined with oxygen to become water vapor. The energy stored in chemical bonds has been released as light and heat. Photons have streamed outward in all directions, bouncing off walls, warming surfaces, racing away at the speed of light. If you could track every atom, every photon, every bit of heat, you would find that the candle is still here, not as a candle, not as a neat cylinder of wax with a bright flame on top, but as dispersed atoms and radiated energy woven into the room around you. The candle did not vanish. It transformed. This is not poetry. It is the first law of thermodynamics. Energy cannot be created or destroyed. It can only change form. Matter, too, is conserved in ordinary chemical reactions. The atoms before the flame are the same atoms after the flame. They are simply rearranged. Physics does not allow for annihilation in the everyday sense. It allows only for transformation. Now shift your attention from the candle to yourself. You are not so different from that flame. Right now, as you sit and listen, you are burning, not with visible fire, but with controlled chemistry. Oxygen flows into your lungs. It enters your bloodstream. It reaches your cell. There, inside microscopic structures called mitochondria. Oxygen combines with the carbon and hydrogen from the food you have eaten. Bonds are broken. Bonds are formed. Energy is released. That energy does not sit idle. It is captured in a molecule called ATP, adenosine triphosphate, the universal energy currency of life. Every movement you make, every heartbeat, every electrical signal in your brain depends on ATP being broken down and rebuilt. At any moment, your body holds only a small amount of ATP, yet you recycle it at astonishing speed. Each molecule is used and regenerated thousands of times per day. Over 24 hours, you will produce and consume roughly your own body weight in ATP. You are a controlled burn that never stops. From the moment you were born until the moment you die, this chemical flame has been maintained. And like the candle, you are constantly releasing byproducts. Each breath you exhale carries away carbon dioxide that was part of your body seconds before. Each drop of sweat releases water and dissolved salts. Every minute, tens of thousands of skin cells fall away. Atoms leave you continuously. Atoms enter you continuously. You feel solid. You feel stable. But physically, you are a flow. A river of atoms passing through a temporary pattern. The pattern is what we call you. Imagine following a single carbon atom It might enter your body in a piece of fruit. It becomes part of a glucose molecule. That glucose is broken down in your cells. The carbon becomes part of carbon dioxide. You exhale it. A plant absorbs it during photosynthesis. Months later, that carbon is part of a leaf. An animal eats the leaf. The carbon moves again. Nothing about the atom marks it as yours. It simply participates in whichever pattern chemistry and biology place it. When the candle flame goes out, what disappears is not the atoms. What disappears is the organized process. The steady inflow of wax vapor stops. The reactions cease. The pattern can no longer sustain itself. The flame was never a thing in the sense of a fixed object. It was a self-sustaining arrangement of reactions. You are like that, a highly complex, highly ordered flame. As long as fuel comes in and waste goes out, as long as energy flows through the system, the pattern persists. Your heart beats. Your neurons fire. Your cells repair damage. Order is maintained against the natural drift toward disorder. So when we ask what happens when you die, the candle gives us the first clue. Nothing material is erased. Nothing energetic is deleted. What changes is the organization. The reactions stop being coordinated. The flame goes out. The atoms remain. The energy disperses. The pattern dissolves. And that distinction between matter and pattern, between substance and process, is the key to understanding everything that follows. The first law tells us that energy cannot be created or destroyed, only transformed, and this is not a poetic statement, but a hard quantitative rule that has survived every experiment we have ever performed. In any closed system, the total energy before a process equals the total energy after. Always, without exception, when chemical bonds break inside your cells, the energy released does not vanish. It becomes motion of molecules, electrical gradients across membranes, heat radiating from your skin. When you lift your hand, chemical energy stored in ATP becomes mechanical energy in muscle fibers. When you think, a thought energy becomes patterns of electrical activity across billions of neurons. When you speak, chemical energy becomes pressure waves moving through air. Nothing is lost. It changes form. Even at rest, you radiate heat into the room at roughly 100 watts. About the power of a light bulb. That heat is not disappearing. It increases the random motion of air molecules around you. Those molecules collide with others and pass the energy along. The walls absorb some of it. The environment absorbs the rest. Over a single day, the total energy your body processes is enormous compared to what is present in you at any instant. Food contains chemical energy originally captured from sunlight by plants. That energy flows through you in a continuous stream. Some becomes motion. Some becomes organized. Neural activity. Much of it degrades into heat, but at no point does it cease to exist. Now consider the moment your heart stops. Oxygen no longer reaches cells. Coordinated chemistry begins to fail. But the energy stored in chemical bonds does not vanish. Electrical gradients collapse into heat. Chemical potential relaxes. The body cools as its heat spreads into the air and ground. The total energy before and after remains the same. What changes is its organization and concentration. This brings us to entropy. Entropy measures how many microscopic arrangements correspond to a macroscopic state. And systems naturally evolve toward states that can be realized in more ways. Heat flows from hot to cold because there are vastly more ways for energy to be evenly distributed than to remain concentrated. Life persists by pushing against this drift. You maintain low entropy inside your body by exporting entropy outward. You take in high energy molecules like glucose. You break them down. You release carbon dioxide and water, more disordered molecules. And in doing so, you preserve the intricate order of your cells. You are not exempt from the second law. You are a local pocket of order made possible by a greater increase of disorder elsewhere. The sun sends concentrated energy to Earth. Earth radiates more diffuse energy back into space. And in that flow, life builds temporary islands of structure. When you die, the active maintenance of that island stops. Without controlled energy flow, gradients flatten. Molecules diffuse. Complex structures relax into simpler states. Entropy increases. But nothing mystical happens. No energy is erased. No matter is annihilated. The same conservation laws apply. The same probabilities govern every reaction. Death is not destruction. It is the loss of organized flow. The universe keeps every joule and every atom. It simply redistributes them. Now we go deeper into what you are physically made of, not as poetry, but as chemistry and numbers. If we take your body and break it down by mass, about 65% of you is oxygen. Most people are surprised by that. But remember, you are mostly water, and water is H2O. And oxygen is the heavy part of that molecule. After oxygen comes carbon at roughly 18% of your mass. Then hydrogen at about 10%, and nitrogen at around 3%. Together, oxygen, carbon, and hydrogen and nitrogen make up about 96% of your entire body. Just 4 elements out of the 92 that occur naturally on Earth account for nearly all of you. The remaining 4% includes calcium, mostly in your bones and teeth, phosphorus, which is essential for DNA and ATP, potassium and sodium, which control electrical signals in your cells, sulfur in certain proteins, chlorine and magnesium in small but vital amounts, and trace elements like iron, zinc, copper, and iodine. The iron in your body, if you could extract it all, would form a small nail only a few inches long. Yet without it, you could not carry oxygen in your blood, and you would die within minutes. A tiny fraction of mass, absolutely essential for the pattern to function. Now shift from mass to counting atoms. By number of atoms, you are mostly hydrogen. About 63% hydrogen atoms, about 24% oxygen atoms, and about 12% carbon atoms. Hydrogen is the simplest atom in existence. 1 proton and 1 electron. The majority of the atoms that make up your body are the simplest building blocks the universe ever produced. Here's something that stretches the mind. There are more atoms in your body than there are stars in the observable universe. The observable universe contains on the order of 10 to the 22 stars. You contain about 7 times 10 to the 27 atoms. That means you have roughly 100,000 times more atoms in your body than there are stars in all the galaxies we can see. You are not small in atomic terms. You are astronomically large. Now ask the next question. Where did those atoms come from? The carbon in your hand was not made on Earth. The oxygen in your lungs was not made on Earth. The calcium in your bones was not made on Earth. If we go back to the very beginning, just after the Big Bang, the universe contained almost nothing but hydrogen and helium, with a tiny trace of lithium. That is all that formed in the first few minutes of cosmic history. There was no carbon, no oxygen, no nitrogen, no iron. Heavier elements had to wait for stars. Hundreds of millions of years later, gravity pulled hydrogen and helium into dense clouds that collapsed and ignited inside stars. Under immense pressure and temperature, hydrogen nuclei fused into helium, releasing energy. That is what makes stars shine. In more massive stars, when hydrogen ran low, the core contracted and heated further. Helium began to fuse into carbon in a delicate process known as the triple alpha reaction. Carbon fused with helium to make oxygen. In even more massive stars, fusion continued, building neon, magnesium, silicon, and eventually iron. Iron marks a turning point. Fusing elements lighter than iron releases energy. Fusing iron absorbs energy. So when a massive star builds an iron core, it can no longer support itself. In less than a second, the core collapses under gravity and rebounds in a catastrophic explosion known as a supernova. In that explosion, temperatures soar above 1 billion degrees. And in those extreme conditions, elements heavier than iron are forged. Gold, platinum, uranium. Many of the heavy elements we prize are created in these brief, violent moments. Some are also formed when neutron stars collide. Events so powerful they shake space-time itself. Then the debris of these explosions spreads into space, enriching interstellar clouds with heavy elements. New stars form from that enriched material. Planets condense from the leftover dust. About 4.5 billion years ago, our solar system formed from such a cloud. Every carbon atom in your body was forged in the core of a star that lived and died before the sun was born. Every oxygen atom you breathe was assembled in stellar furnaces billions of years ago. This is not metaphor. It is measured nuclear physics. You are literally made of star matter. The atoms in your blood, your brain, your bones were once inside stars. They were blasted across space, drifted for eons, gathered into a planet, became part of oceans and rocks and living cells, and eventually became part of you. So when you think about death, remember this. The atoms that make you are ancient beyond imagination. They have already lived cosmic lives before you borrowed them. They will continue their journey long after the pattern that is you has dissolved. Now consider something even stranger. Most of the atoms in your body were not there a year ago. Studies using radioactive tracers have shown that roughly 98% of the atoms in your body are replaced over the course of a year. The water in you turns over in a matter of weeks. Half the water molecules in your body today were not there 2 weeks ago. You drink, you sweat, you breathe out water vapor, you urinate, and new water flows in. The river never stops. The cells lining your stomach last only a few days before being destroyed by acid and replaced. Your skin cells live a few weeks. Your red blood cells circulate for about 4 months before being broken down and recycled. Even your bones, which feel permanent and solid, are constantly being dissolved and rebuilt. Specialized cells break down bone tissue while others lay down new mineral, quietly reshaping your skeleton year after year. Some cells are more stable. Many of the neurons in your brain have been with you since childhood. Certain cells in your heart renew very slowly. But even these long-lived cells are not static. The molecules inside them are constantly being repaired, replaced, shuffled. Proteins are built and dismantled. Lipids are swapped. Ions flow in and out millions of times per second. The atoms that made up your body when you were 10 years old are almost entirely gone, scattered into the air, the soil, the ocean. Some may now be part of other people. Some may be part of trees. Some may be drifting high in the atmosphere. Yet you feel continuous. You remember being 10. You experience yourself as the same person. So what persists if not the atoms? What persists is the pattern, the organization, the information encoded in the structure of your brain and body. Think of a whirlpool in a river. The water molecules that make up the whirlpool are constantly changing. New water flows in. Old water flows out. Yet the whirlpool as a shape persists. It is not a fixed collection of specific molecules. It is a stable pattern sustained by flow. Or think again of a flame. The flame of a candle is not made of particular atoms. Fuel molecules enter. Combustion products leave, and yet the flame remains recognizable as long as the process continues. The flame is a dynamic structure maintained by energy flow. You are like that. A highly complex, self-sustaining pattern in a stream of matter and energy, as long as the flow is regulated and coordinated. The pattern persists. Your heart pumps. Your lungs exchange gases. Your neurons communicate through electrical and chemical signals. Billions of cells cooperate, guided by DNA instructions and biochemical feedback loops. Death, then, is not the disappearance of atoms. It is the collapse of coordination when oxygen no longer reaches cells, when energy production fails. The delicate balance that maintained your structure unravels. Membranes lose their gradients. Enzymes that once built molecules begin breaking them down. The immune system no longer restrains bacteria in the gut, and they spread. The organized pattern dissolves into simpler chemical states. The second law of thermodynamics quietly takes over. Without energy flowing in a controlled way, entropy increases. The highly specific arrangements that defined you give way to more probable configurations. Molecules diffuse, structures fragment. The island of order melts back into the wider sea of disorder. But remember this, even in decomposition, nothing is wasted. The carbon atoms in your body return to the atmosphere as carbon dioxide or become part of the soil. Plants absorb that carbon through photosynthesis. Animals eat the plants. Microbes break down remains and recycle nutrients. Without decomposition, carbon would be locked away and life would eventually halt. The end of one pattern becomes the beginning of another. Consider a calculation sometimes called Caesar's last breath. When Julius Caesar exhaled his final breath, it contained on the order of 10 to the 22 molecules. Over 2,000 years, those molecules have mixed throughout the atmosphere. The air is constantly stirred by winds and weather. Statistically, with each breath you take, there is a high probability that you inhale at least one molecule that once passed through Caesar's lungs or Cleopatra's or countless others. The atmosphere is a shared reservoir of atoms, cycling endlessly. You are not a sealed object. You are open to the world at every moment. You exchange atoms with the air, with food, with water, with the ground. The boundary you feel as your skin is real biologically. But at the atomic level, it is permeable and temporary. So the deeper answer to what happens when you die is this. The pattern that was uniquely you, the coordinated dance of molecules and signals, stops being maintained. The atoms continue. The energy continues. The information encoded in your brain may echo in other brains through the memories and influences you leave behind. But the specific dynamic arrangement that called itself you dissolved. You were never a static object. You were always a process. Now let us widen the scale even further and ask what ultimately happens to matter and energy in the long run. We have seen that atoms are conserved and that patterns dissolve when energy flow stops. But the universe itself is not static. It evolves under the same laws of thermodynamics that govern your body. Entropy increases not only in organisms, but across cosmic time. If we project those laws forward, we arrive at a picture both stark and profound. In about 5 billion years, our sun will exhaust the hydrogen fuel in its core. Without fusion pressure to hold gravity back, the core will contract and heat up, causing the outer layers to expand enormously. The sun will become a red giant, swelling outward perhaps beyond the orbit of Earth. The oceans will boil away long before that expansion reaches its maximum. The atmosphere will be stripped. Any trace of life on this planet will be erased. Eventually, the outer layers of the sun will drift away into space, forming a glowing shell of gas, and the core will collapse into a white dwarf, a dense sphere of carbon and oxygen, roughly the size of Earth, but containing half the mass of the original sun. That white dwarf will slowly cool for trillions of years, radiating its remaining heat into space. But this is only our local story. On larger scales, the universe continues to expand. Galaxies move apart as space itself stretches. In about 100 billion years, distant galaxies will recede beyond our cosmic horizon, their light stretched and dimmed until they are no longer visible. The sky will grow darker as fewer stars remain within view. Star formation itself will decline as the gas needed to build new stars is gradually consumed or locked away in stellar remnants. Over trillions of years, the last red dwarf stars, which burn their fuel extremely slowly, will finally fade. The universe will enter an era dominated by stellar corpses, white dwarfs, neutron stars, and black holes. These objects will persist for unimaginable spans of time. If protons are truly stable, ordinary matter could endure for periods vastly longer than the current age of the universe. If protons eventually decay, as some theories suggest, even atoms will slowly disintegrate over timescales of 10 to the 34 years or more. Black holes themselves are not eternal. According to quantum theory, they emit faint radiation and gradually lose mass, a process known as Hawking radiation. Over timescales of 10 to the 67 years for a black hole, the mass of our sun, or 10 to the 100 years for supermassive black holes, they too will evaporate. What remains will be an extremely dilute bath of particles and radiation spread thinly across an ever-expanding cosmos. This projected end state is often called the heat death of the universe. It does not mean flames or destruction. It means uniformity. Temperature differences disappear. Energy gradients vanish. Without gradients, no work can be done. No stars can shine. No chemistry can assemble complex structures. Entropy reaches a maximum. The cosmos becomes cold, dark, and nearly featureless. From this perspective, every organized structure is temporary. Stars are temporary. Planets are temporary. Life is temporary. You are temporary. Yet temporary does not mean insignificant. It means improbable and remarkable. For billions of years, the universe was a simple plasma. Then gravity sculpted stars. Stars forged heavy elements. Planets formed. Chemistry became biology. Biology became consciousness. Matter arranged itself into patterns capable of reflecting on their own existence. You are one such pattern. You exist during a brief era when the universe still has usable energy, when stars shine and entropy has not yet flattened all differences. In this narrow window, atoms can gather into living systems. Information can be stored in DNA and brains. Questions can be asked. When you die, your personal pattern dissolves, but the cosmic story continues. Your atoms re-enter planetary cycles. The Earth itself will eventually be recycled as the sun evolves. The heavier elements forged in ancient stars will persist in stellar remnants and perhaps in future generations of cosmic structures. Even if the universe drifts toward heat death, every transformation along the way obeys the same conservation laws. Nothing is ever thrown away. Seen this way, death is not an isolated event. It is a local instance of a universal rule. Structures arise where energy flows. They persist for a time, and they fade when gradients disappear. The universe has been doing this for 14 billion years. You are one expression of that long process. There's a strange comfort in recognizing that your existence is woven into such a vast arc. You are not outside the cosmic story. You are a chapter within it, written in atoms, forged in stars, and sustained by sunlight. And when your chapter closes, the material remains in the book, rearranged into new sentences, new forms, new patterns. Up to this point, we have spoken about atoms as if they were tiny solid beads, little marbles that travel through space and occasionally gather into stars, planets, and people. But modern physics tells us something even stranger. At the deepest level, atoms themselves are not fundamental objects. They are structures built from particles. And those particles are not really objects either. They are excitations of underlying fields that fill all of space. Imagine a field as something that has a value everywhere, like temperature in a room or pressure in the ocean. Even if no one is there to measure it, the field exists at every point. Quantum field theory tells us that what we call a particle is a small vibration in such a field. An electron is not a tiny solid sphere flying through emptiness. It is a localized ripple in the electron field, a disturbance that behaves in certain predictable ways. The same is true for quarks, photons, and the other fundamental entities of nature. There is only one electron field permeating the entire universe. Every electron that has ever existed, whether in your brain or in a distant galaxy, is an excitation of that same field. That is why all electrons are identical. They are not copies of one another. They are manifestations of the same underlying reality. So when you think of the electrons in your body, they are not separate from the electrons in a star millions of light years away in the sense of being made from different stuff. They are ripples in the same continuous fabric. The boundary between you and the rest of the cosmos is real at the level of biology and chemistry. But at the deepest level, it is a convenient description. Not an absolute separation. Even what we call empty space is not truly empty. The quantum fields remain present even in a vacuum. They fluctuate. They vibrate. Pairs of particles and antiparticles can briefly appear and annihilate again in accordance with the uncertainty principle. These vacuum fluctuations have measurable effects. They shift the energy levels of atoms. They create tiny forces between closely spaced metal plates. The vacuum is active, not inert. This means that the stage on which your life unfolds is not a passive void. It is a dynamic, a restless medium. The atoms in your body are structured vibrations in a deeper sea of fields. When we say your atoms scatter at death, we are speaking at one level of description. At a deeper level, the specific pattern of vibrations that constituted your body reorganizes into other patterns within the same underlying fields. From this perspective, separateness becomes more subtle. You are not a chunk of matter cut off from the universe. You are a temporary configuration of universal fields. The same electron field that forms the atoms in your neurons also extends beyond your skin, beyond the Earth, beyond the galaxy. The same photon field that carries light from the sun into your eyes extends across billions of light years. When you are alive, the vibrations in these fields are arranged into an extraordinarily intricate structure. Signals propagate along neurons. Chemical reactions follow precise pathways. Feedback loops maintain stability. The pattern is coherent and self-reinforcing. When you die, that coherence breaks down. The fields do not vanish. The vibrations do not cease to exist altogether. They rearrange. They lose the coordinated structure that made them part of you. At the deepest level, nothing fundamental is ever truly lost. The fields persist. Their excitations change. Energy redistributes. Entropy increases. But the underlying fabric remains. This does not grant personal immortality, the specific organization that allowed you to think. Remember, and field does not spontaneously reassemble elsewhere. The pattern was contingent on countless conditions, on metabolism, on neural connectivity, on continuous energy flow. Once those conditions fail, the pattern dissolves irreversibly. Yet there is something astonishing in realizing that what you call yourself was never an isolated object to begin with. You were always a process in a continuous field. The atoms that formed your body were not fundamentally separate from the atoms in distant stars. The particles were not independent units, but ripples in shared fields. When you die, the universe does not discard matter. It does not delete energy. It does not tear a hole in the fabric of reality. It simply allows one intricate vibration pattern to relax into others. The same fields remain, waiting for new structures to arise where conditions permit. Seen this way, your existence is not a foreign intrusion into the cosmos. It is a natural expression of the laws that govern everything. You were the universe in a particular arrangement, briefly capable of asking what happens when you die. We have followed your atoms from stars to cells, from metabolism to entropy, from fields to cosmic expansion. Now we can return to the original question with a clearer lens. What happens when you die? Physics gives a sober and surprisingly elegant answer. Your atoms disperse. Your energy spreads. The organized pattern that sustained your thoughts dissolves. But nothing fundamental is destroyed. It is important to be precise here. The persistence of your atoms is not the same as the persistence of you. A carbon atom that once participated in the neural activity of your brain does not carry a memory of your experiences. It does not retain an imprint of your personality. It is simply a carbon atom. 6 protons, 6 neutrons, 6 electrons, behaving according to the same laws as every other carbon atom in the universe. What made it part of you was its position within a highly specific network of relationships, a pattern of connectivity and energy flow. When that network collapses, the atom returns to anonymity. So there is no hidden storehouse in which your personal identity is archived in matter. The pattern that was you depended on ongoing processes. It required oxygen, glucose, electrical gradients, constant repair and renewal. Once those processes cease, the pattern cannot sustain itself. In thermodynamic terms, the low entropy structure relaxes toward more probable states. And yet there is another layer to consider. While your atomic configuration does not survive as a self-aware entity, the effects of your existence propagate outward. Every conversation you had altered the brains of others in subtle ways. Neural connections strengthened or weakened. Memories formed. Ideas were transmitted. Every action you took had consequences, setting chains of cause and effect in motion. Those changes ripple forward through time. Information can outlast its original physical arrangement. A book persists beyond the life of its author. A scientific discovery continues to shape understanding long after the discoverer is gone. A kindness may echo through generations. These patterns are not supernatural. They are physical modifications in other brains, in written symbols, in social structures. They are part of the evolving web of matter and energy. In that sense, while the specific dynamic organization of your brain ends, the traces it left in the wider system do not vanish instantly. They diffuse, transform, combine with other influences. Just as energy spreads but is conserved, influence spreads but remains embedded in the ongoing process of the world. If we zoom out one final time, we see that your life was a rare configuration made possible by a particular cosmic era. The universe began in simplicity. Over billions of years, it generated complexity through gravity and nuclear fusion. It created heavy elements, planets, chemistry, biology, and eventually organisms capable of reflection. You were matter that had arranged itself into a form able to ask about its own fate. When you die, the universe does not lose mass. It does not lose energy. It loses one intricate way of organizing them. It loses one particular perspective, one set of questions, one stream of experiences. That arrangement will not spontaneously reassemble in the same way. The probability is effectively zero, but the underlying material remains available for new configurations, new structures, new forms of complexity, as long as cosmic conditions allow. There is something profound in recognizing that you were never separate from the cosmos to begin with. The hydrogen atoms in your body were forged in the first minutes after the Big Bang. The carbon in your cells was built in the heart of a dying star. The energy flowing through your metabolism originated in nuclear reactions in the sun. The fields that underlie your particles extend throughout space. You were a temporary eddy in a river of matter and energy that has been flowing for 14 billion years. For a brief interval, that eddy became conscious. It contemplated its own origins. It measured the age of the universe. It calculated the fusion reactions in stars. It wondered what would happen when it ceased. And the answer, stripped of myth and ornament, is this: nothing essential is erased. The components remain. The organization changes. The pattern dissolves into the larger flow. That is not a promise of personal immortality. It is a statement about continuity. The same laws that brought you into being carry you forward into transformation. You are always part of an ongoing cosmic process. Death is not an exit from that process. It is a change in how the process is arranged. If you would like, I can now help you condense this entire script into a tighter YouTube narration version with stronger emotional pacing and rhetorical rhythm.